is some real straightforward, pretty easy things to work with. What we're dealing with today are called inverse functions. And for most students that we've talked about with this stuff so far today, is that you're able to see the inverse stuff, how it works, real easy. I found out today that it's a little bit nicer if I kill one of them, you can see the less glare, especially when it's not as sunny as earlier. Now, what happens here is I don't want you to copy this table down. I don't want you to worry about it, but I want you just to look at this next table and tell me what you see happening between an original relation and an inverse relation. What swaps? Okay, that's 7.4. What happens with an inverse relation when we're talking about an inverse function is that in order to show that you have an inverse, the x's and the y's flip-flop. For example, if I have f of x equal to 2x minus 1, and I want to find its inverse, the way that we denote inverse, well, you've seen this notation before. When we did inverse matrices, what button did you press on your calculator? The -1. So when I talk about an inverse function, the inverse function is f inverse of x. And what is f of x synonymous with again? Y equals, good. So the inverse of this is nothing more than exchanging the x and the y values and resolving for y. If I rewrite this out in terms of y equals 2x minus 1. The inverse of it is this. X equals 2y minus 1. No, all I have to do is solve for y now. Now solve for y. All you do is exchange the x's and the y's and resolve it. Yes, sir?
So you're solving for x. So pretty much, like, and then you're just changing the name of it.
If you want to think of it that way, yeah. But you always start by exchanging the x and the y. I add 1, and then I divide by 2. And there's the inverse of the original function. You don't see too much of it right now in Algebra 2, but you use inverse functions quite a bit in pre-calc. So a lot of this stuff today is kind of like get your mindset of what it means to become an inverse. What do you have to do in order to solve for the inverse? Just remember, you're flip-flopping your x's and y's and resolving the equation for y. Not so scary? All right. Well, you'll be all right. Speaking of which, I need autographs. It was in the midweek, and I couldn't find anyone. I tried my best. Yeah. Now you know what it's like to read his handwriting.
What is your name?
Perfect.
Nice.
What is your name?
Something.
And then I got another one. Oh! Look, I had like a 2-for-1 today. But it was in the paper. But I felt that I couldn't find either of them as a digital image. Otherwise, I would have used the digital one, and I had to scan a newspaper. I felt like such a
The one on the right.
such like 1987.
It's your signature. It has to be in cursive.
I don't care.
It's your signature.
Don't you know how to sign cursive? Don't write it on the picture because you can't see it now. It won't be as cool. And I'll do it.
I have to erase that.
You're on the right, aren't you?
Are
you left-handed? Oh, Brittany.
Did you forget how to spell your name?
I
I'm just messing with you. Anyway.
Roll.
And I'll print them out in a minute.
Brittany.
Again, all we're doing here, guys, in order to solve for an inverse, is if my original equation is y equals 2x minus 4, if I want to find the inverse of it, if they write it out in terms of y equals, my inverse instead of being f prime of x would be, or not f prime, f to the -1 of x would be y to the -1 would equal, well, How do you solve that?
Add 4 divided by 2.
Add 4, divide by 2. Do you agree?
Yeah.
Okay, so we have x plus 4 all over 2. And in this case, I can simplify that down a little bit more. Can I write it as 1/2 x plus 2? That's inverse functions. The weird stuff comes into play. Yeah.
So then do you write that answer you got, like y minus y to the negative
Yeah.
1 equals whatever answer you just got?
And I'm going to show you, there is a relationship between these two. I'm going to show you guys in a minute, okay?
Okay.
I just want to get you in the habit of how you're solving these things out. Because so far we're just working with linear. We haven't gotten to the power functions yet. Yes, sir.
So you left it out right.
Oh, I was saying the inverse of the y equals is going to be the following. That's all. That's all it is. Now, what gets weird, what's x over 2? 1/2 x. That's all. I just rewrote it as 1/2 x. No. No. There's really nothing to do with the calculator on this one, except when we get to the power functions. Do you guys remember? Do you remember when you graphed lines and functions? You were able to tell whether or not something was a function when you graphed curves? Do you remember how you were able to tell if something was a function? What test did it have to pass in order to tell if something was a function? It had to pass the vertical line test. Now, if you remembered, if you were looking for the vertical line test, in order for this to work, in order for something to be a function, as you drew a vertical line through the graph, that vertical line can only touch the graph in one place throughout the curve. If that passed, then you could say it was a function. So, parabolas, functions, right? Now, when they're twisted on their side,
Not a function
not a function.
at all.
This is a cubic function. Is that going to be a function? Yeah, that'll also be a function. So what happens now is that when you get to your power functions, you have to be very careful about telling whether or not you're going to have a function that is, an inverse that is a function. And there's a way to test this. If I test an original equation with a vertical line, what's the inverse of a vertical line?
Horizontal.
A horizontal line. So if I want to check if a power function is going to be, or is going to have an inverse that is a function, I have to test it with a horizontal line. So here's what happens. When you have a curve, we're going to use a parabola. I'm not centering the parabola over anything at all. It could be at the origin. It could be any quadratic whatsoever. But whenever you have a parabola and you want it you're going to see if it's going to pass this horizontal line test. If you draw a horizontal line through it and it touches it in two spots, will the inverse of that be a function? No. Because the inverse of a parabola looks like that. The inverse of a parabola spins itself depending upon where it is placed. It spins itself. And the horizontal line becomes a vertical line. And a vertical line, if it touches the graph in two spots, isn't a function.
So if it's on its side, the inverse is
Yeah, it can be up, it can be off to the sides, depending upon what direction it goes. Okay. Yes, ma'am?
But in like the first test, wouldn't you use the vertical line first?
Well, you're given the fact that it already is a function. It's telling you f of x. Let me show you, I know what you're thinking here. Let's use f of x is x squared. We all agree that an x squared is a parabola that goes through the origin, correct? So if I have my origin, I draw my curve, it'll look like that. Since it was denoted as f of x, it's telling you right now function of x. it's saying that it is a function to begin with. So there's no need for to use that vertical line test through that. Does that make sense? What I want to check though is, will that inverse be a function? And a way to check to see if anything that has a power, any of the power functions here, anything with a degree, if it, when you look at it in a graph, doesn't mean you have to do it by hand. If you use your graphing calculator, if you can put a horizontal line through it, and it touches in two places, that means that the inverse of x squared does not exist.
So that's just testing the inverse.
Yep.
It's not testing the C.
Yep, oops, use the horizontal line.
And it can be both.
What's that?
It can be both.
What do you mean?
Like, it can pass from the horizontal and the vertical line test.
It could, yeah, and I'm going to show you what happens here. So what happens here is when you're looking at these power functions, the first thing you want to do is put it in your graphing calculator and see if you can draw a horizontal line through it. That's all you want to be able to do. If you can put a horizontal line through it and it touches two spots, your inverse won't exist. Yes, sir?
So like a parabola won't ever have an inverse?
And that's what I'm getting at. Unless, there's always the unless,
Unless,
it changes the domain.
oh, what is domain? I think
The x
they were saying
values.
that on the homework.
In this example, yeah,
Within the square root of x, it's like half the parabola.
correct.
Yes.
Because what happens there, you didn't take plus minus. Ah. Now here's what happens. If I say I want to look at this for all x values that are greater than or equal to 0, what part of the graph am I looking at?
Right.
So I don't care about the left side of the graph anymore, do I?
Oh, so it is a function.
So now, does it still pass that horizontal line test? It does pass the horizontal line test. So will the x squared, the f of x equals x squared for all x values greater than 0 have an inverse?
Yes.
Yes, it will. It will have an inverse because it gave you some domain to worry about. So all you have to be careful with when you're dealing with these power ones is to look at the graph and look at if they give you some domain restriction. Here they give you a domain restriction. Yes, sir?
What if it was like, you move that over the parabola?
I just made it look like it was still at the origin. That's all. I just messed with it.
Well, like what if it was all, the parabola was all on the side that was greater than x equals 0?
But that's what it is.
No, like the
I do
whole
not sound
parabola.
dumb. No,
was
that's what I meant.
Oh,
Yeah,
the whole
yeah.
parabola was over here?
Oh, do I sound dumb?
No, but take a look. Even if it was still given at this value here at x equals 0, it doesn't pass the horizontal line test.
So
What
then
it-
it wouldn't.
Unless it gave it through the axis of symmetry, saying, let's say this is at 3, and this was greater than or equal to 3.
Right.
You have to pay attention to your domain where the stuff's going through. Don't freak out. You're probably not ever going to see anything that complex. That's a great question, but I don't think you're going to see anything like that. Yes, ma'am.
So it's like, say one side was like shorter than the other, like it was trying to do the horizontal test then?
Yeah.
So the domain stopped at a certain place, and the one side was shorter. So then the horizontal test wouldn't work then, because you could put it,
Correct. Yeah.
okay.
Correct. You want the horizontal, you want the domain to be restricted from the vertex either to the
Okay.
left or to the right, depending upon what it's asking you to do. Yeah.
That's my question.
Okay. Because here, when I do this, if I go to solve for my inverse then, again, this is y equals x squared. I'm looking at all positive values of x. I exchange the x and y, so I say x is equal to y squared. How do you get y by itself?
You gotta divide, or root.
You square root it. And just like Andrew was saying, you know how you took the square root there, you did the square root of x was y, and then the curve, this wasn't here, looked like this. Now, do I have to do plus minus here?
Yeah.
No. And why don't I have to do plus minus? I'm assuming that it's looking for all positive values of x. Okay? Because I'm only looking at the positive values of x.
Yeah.
Does that Does that change though if it said, if it was f of x, we'll use the x squared again, where x is less than or equal to 0.
Now, does that be the second and third quadrant there?
I'm looking at that graph. Will that graph have an inverse? Yes. So when I do that, I do the same thing. X would equal to y squared. So I'm looking at square root of x for y, but these all have to be the negative ones because it'd be less than 0. That domain part at the end of some of these power rules is just something to make sure you pay attention to your sign. It's going to cut one of your curves in half, especially for parabolas. You're not going to see it very often, if at all, when you're dealing with odd powers, because most odd powers always have that up and going like the cubic function does. Yeah.
For the test of the 9 times better
I don't think so.
What about the quiz?
It's all on that.
Oh, for the quiz? I don't think so. I don't know.
Oh yeah, it's just all 9 all on
You don't know,
that.
it's the
I know.
one.
I can't tell you.
You do know.
I do know.
There's a quiz.
And the
It's a quiz name. Oh yeah.
The last bit of this stuff is what we call verifying. There's two parts to this section. There is find the inverse, which we just did, and there is verify this is an inverse. What happens when you're verifying inverses is you're using that composite stuff that you guys were doing yesterday, f of g of x, g of f of x. But instead of saying f of g of x or g of f of x, you're saying f of f inverse and f inverse of f. You're using the same premise. And I want you guys to see what happens here. Excuse me. If these guys are inverses of one another, if 2x minus 4 and 1/2 x plus 2 are inverses of each other, they should, when you substitute in for each other, equal the same value. Remember, if I'm trying to find f inverse of x of f, I start by writing out the inverse equation. Then I surround it with the f equation. Distribute. And what do you get? X. Okay? I do the same thing with the other set of equations. Again, I start by writing down the f of x equation, which is 2x minus 4. And then I surround it with all the rest of the inverse equation without the x. And I distribute that one and simplify. Half of 2 is? I get x minus 2 plus 2. What do I get? Hey, did they both equal x?
Yes.
If, when you verify stuff out, if your answer is x for both of them, that means they're inverses of one another. And you're lucky. And you're lucky, yes. So if this equals x and this equals x,
Slam dunk it. Come on.
you're happy. That means they're inverses of one another.
That's such an awkward.
Sure, I didn't know you were on the board.
Okay.
Gotta go
So what
back.
happens again, in order to verify if something is an inverse, all you're doing is substituting in for each other and trying to see if you wind up with x after you do that.
Oh, if they should all go up.
They should. If they don't, that means that they're not inverses or you made a mistake. So double check, because sometimes they might not be inverses. So you always just go back and double check, make sure you didn't mess something up. A lot of times what you'll forget is sending the 2 over here. So that's what you guys will mess up.
So you're gonna ask, like, is the problem that you're gonna ask us, is this?
Are these, yeah, it'll say, verify these 2 are inverses. And this is how you verify. Other ones were find the inverse equation. That's the only 2 differences of this section. But obviously, when you have to find inverse, verify inverses, sometimes you get power functions. Okay? Don't worry. Again, you're going to use the same properties and tools of all of the exponent rules that we've been working with. Here again, they're saying verify that f and g are inverse functions. Which means I start again, I have f of x is 8x to the third. G of x is x to the 1/3 all over 2. Yeah. So in order to verify, we take all of the g equation, we write it down, and I surround it with the f equation without the variable. And now I have to go back and rely upon my exponent rules. I have a fraction raised to a power, but also in the numerator, I have a power rule to worry about. So if these two guys I have to multiply, what's 1/3 times 3?
1.
So I have 8x, and then here I have to distribute to here, what's 2 cubed? What's 8 over 8? So I get x. So the first one worked out clean. The first one worked out clean. I check it again going the other way. When I go the other way, I start by writing down. This one just sit there. When I go the other direction, I start by writing down the f equation, and then I surround it with the g equation without the variable. So I have to put this to the third, and then divide it by 2. When you raise something to the third power, what does that mean also? The cube root, okay? What's the cube root of 8? 2. And again, I have power to power. What's 3 times a third? 1 again. You get 2x over 2, which is x. Are they inverses? Yep. That's about as nasty as this stuff looks. You just have to worry about going through with your exponent rules. Okay? So far today, when I've had everybody else going through this, they felt that this is probably the easiest section. But you have to remember, when we get to the quiz tomorrow, there's all 3 sections are valid, or 4. Excuse me, I can count. All right, the quiz is written, so you guys should be done with it in about 20, 25 minutes at the tops. That means I'm expecting you guys to have a couple of quick questions before we take it. I have planned on maybe 7, 8 minutes. If you have questions from the homework that we do tonight, and if you have any leftovers from 7-1 through 7-3. And then after that, the rest of the time is going to be, I'm going to allocate to make sure there will be at least 35 minutes for you to take this quiz. I don't think it'll take you more than 20. It's short. Okay? I will not be starting anything new. So you guys will go on the weekend with nothing else to do. All right, questions? I'm giving you odd problems again.
Oh, that's so odd. For some reason, it's not odd for you to give us odd problems.
Giving you those guys to start with, so that way you can check your work.